Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the WHO guidelines for drinking water with ammonia when it comes to understanding what it is and how it works. So the WHO document dealings with public drinking water was first published in 1958 and was revised in 1963 and 1971. And taking a look at that, we can take a look at ammonia and understand a little bit more about it. So first, we're going to take a look at the major uses, the environmental fate, the method, and how it affects water. So first, the major uses are ammonia is used in fertilizer and animal feed production, and in the manufacture of fibers, plastics, explosives, paper, and rubber. It is used as a coolant in metal processing and as a starting product for many nitrogen-containing compounds. Ammonia and ammonium salts are used in cleansing agents and as food additives, and ammonium chloride is used as a diuretic. Also, the environmental fate. In the dissolution of water, ammonia forms. The ammonium cation, the hydroxyl ions, are formed at the same time. The equilibrium constant of the reaction, the degree of ionization, depends on the temperature, the pH, the concentration of dissolved salts in the water. And the environmental cycling of nitrogen relies mainly on nitrate, followed by the ammonia and the ammonium cation, which predominates. The ammonium cation is less mobile in soil and water than ammonia is involved in the biological processes of nitrogen fixation, mineralization, and nitrification. And we also have the analytical method. Ammonia and ammonium cation at concentrations between 0.025 and 3 milliliters can be determined by endothelial reaction or an ammonium selective electrode. It can also be used as trimetary, which is less sensitive. So how does it affect things like air, water, and food is the big question. Air in urban areas contains up to 20 grams of ammonia per m air in urban areas, which contains up to 20 of m air in urban areas and 20 Ug of ammonia per milliliter in areas where farm animals are intensively reared, may contain levels as high as 300. Also with water, which is the one that we really want to know, levels in groundwaters are usually below 0.2 milligrams of ammonia per liter and higher natural contents, and found in strata rich in humanic substances or iron or forests. And surface waters may contain up to 12 milligrams per liter. Ammonia may be present in drinking water as a result of disinfection with chloramines. The presence of ammonia at higher than geogenic levels is an important indicator of fecal pollution. Taste and odor problems, as well as decreased disinfection efficiency, are to be expected if drinking water containing more than 0.2 milligrams of ammonia per liter is chlorinated, as up to 68% of the chlorine may react with the ammonia and become unavailable for disinfection. Cement mortar used for coating and the insides of water pipes may release considerable amounts of ammonia into drinking water and compromise disinfection with chlorine. And the presence of elevated ammonia levels in raw water may interfere with the operation of manganese removal filters because too much oxygen is consumed by nitrification, resulting in moldy, earthy tasting water. The presence of ammonia caution in raw water may result in drinking water containing nitrate as a result of catalytic action and the accidental colonization of filters by ammonium oxidizing bacteria. It's also a natural component of foods as well, and it has different compounds that are added to foods as acid regulators, stabilizers, and flavoring substances and fermentation aids. So that's a little background on how the WHO views ammonia, the good and the bad sides of it. We can see that there's definitely cause for concern, so it's always a good idea to have your water periodically tested for high levels of ammonia.